If you plunge your spacecraft into a black hole, Hollywood tells us you might end up in a glowing five-dimensional tesseract where you can talk to your past self. But is that accurate to the physics? For decades, even Albert Einstein doubted these objects existed in reality. They appeared in equations as bizarre mathematical anomalies, places where our entire understanding of space and time seemed to simply break down. Today, we are going to journey from the safe limits of the Milky Way straight down to the event horizon to see exactly how these invisible entities operate. Black holes are active engines of extreme gravity that violently shred their surroundings, leaving a clear trail of physical evidence across the galaxy. To understand the threat, you have to look at how a star lives. Every active star exists in a delicate balance. Nuclear fusion in the core pushes immense pressure outward, while gravity pulls everything inward. If a star surpasses the Chandrasekhar limit, that balance fails. The nuclear fuel runs out, pressure vanishes, and gravity permanently wins. The dying star collapses and rebounds in a massive supernova explosion. What remains is a stellar mass black hole. The entire mass of a huge star gets crushed down into a sphere incredibly dense, and sometimes only about 50 kilometers across. That is just the small end of the scale. At the center of almost every galaxy lies a supermassive black hole, containing the mass of millions or even billions of suns. In both cases, the gravitational pull is so intense that nothing, not even a particle of light, is fast enough to escape its grip, making the object completely invisible to the human eye. This creates an obvious problem for astronomers. If an object traps all light, how do you prove it actually exists in space? You look for the destruction it causes. Many stars exist in binary systems, orbiting a partner. If one becomes a black hole, it starts stripping gas right off its visible companion, pulling that material into a swirling ring called an accretion disk. As the gas whirls chaotically toward the center, intense friction heats it to 100 million Kelvin, emitting flickering X-rays. This data table lists confirmed binary systems. By detecting specific X-ray emissions and measuring the visible companion star's orbital speed, astronomers calculate the exact mass of the invisible object pulling on it. We never observe the black holes directly. We map their locations entirely by tracking the violent destruction and radiation they inflict on the stars around them. When you scale this process up to the supermassive black holes at the center of galaxies, the destruction becomes system-wide. Because they gorge on so much gas so quickly, their feeding is incredibly inefficient. The supermassive black hole cannot consume everything falling into it. The surrounding friction generates active galactic nuclei outflows. The black hole ejects high-energy particles outward into space at roughly 10% the speed of light. These cosmic winds act like heavily amplified hurricanes, bombarding the surrounding solar systems with intense ultraviolet radiation and sheer kinetic force. The impact is devastating. The radiation and outward pressure from these winds are strong enough to completely strip the atmospheres off Earth-like planets up to 3,000 light-years away. Proximity to an active supermassive black hole guarantees the complete and utter erasure of planetary habitability. If you are in that radius, your planet is sterilized. We have physical proof of these extreme forces at work. When two of these massive bodies collide, they send literal ripples through the fabric of space-time, which we map using large ground-based observatories. If we zoom back in, what actually happens to an individual crossing the event horizon, the point of no return where gravity reaches its absolute extreme? First, you experience gravitational time dilation. The intense pull of the black hole warps time itself, slowing your biological clock down completely relative to an observer safely out in the rest of the universe. Physically, the forces are lethal. Because the singularity at the center is a microscopic point, the gravity pulls exponentially harder on your feet than on your head. You are stretched vertically and squeezed horizontally in a biological process appropriately named spaghettification. The tidal forces simply overpower the chemical bonds holding your body together. Long before you ever reach the singularity itself, you are ripped apart into a continuous stream of individual atoms. There is no magical five-dimensional gateway waiting on the other side. Crossing the threshold guarantees absolute physical and temporal annihilation. Fortunately, you don't need to worry about our local supermassive black hole, Sagittarius A star. Sitting at the center of the Milky Way, it is safely located 26,000 light-years away from Earth. These invisible monsters remain the ultimate testing ground for the limits of physics. If you want to understand what happened before those laws of physics even existed, hit subscribe and join us for our next episode diving into the exact moments of